Hi, good afternoon to everyone. I'm Federico Modica from University of Palermo. I'm an agricultural economist, and a huge thanks to Gary for the opportunity to take part in this conference. I truly appreciate your support and trust. And today I'm going to talk about the economic implication Pfas contamination for agri-food supply chain through a Pigouvian framework. Obviously, the PFAS contamination is typically studied as a toxicological and environmental problem, and this contribution argues it is equally an economic problem. And the key question is that is not only whether PFAS are harmful, but who pays for the damage when costs are invisible in the market price. We are going to see the economic implication through a Pigouvian framework. But these contaminants are called PFAS, and the PFAS are a class of synthetic chemicals used across industrial and consumer application for water, oil, and heat-resistant properties, and their extreme chemical persistence, often called forever chemicals, means that environmental release doesn't reverse. Especially European Commission estimates in 2024 the quantifiable annual health cost from PFAS pollution reached over 40 billions per year, and the soil remediation and water treatment cost added a further 4 billion per year. But the economic question is who absorbs this cost. Obviously, emphasize that water, soil, and food and health are not merely ecological concerns. They are an entry point for through which external costs move into the agri-food economy. So this contribution is focused on a research gap. In fact, the literature of PFAS focuses its attention on toxicological, environmental chemistry, and regulatory sciences, and health risk assessment. But economic theory has been largely absent, and this contribution filled this gap by applying Pigouvian welfare economics to PFAS contamination, and the important thing is that interpreting persistent chemical pollution as a negative externality in which the private use of PFAS generates benefit captured by firms, while the social costs are dispersed across communities, public budget, and future generation. And the contribution is related to a coherent theoretical framing, the application to agri-food supply chain, and a policy discussion grounded in welfare economy. But especially from economic point of view, Pigot identify the negative externalities as a case when marginal social cost exceed marginal private cost. Obviously, the marginal social cost is the total addition cost generated by one or more unit of production or use, including both private and external cost, while marginal private cost is the additional cost directly paid by the producer or user one mm, mm, for one more unit of production. And the last, or else the marginal external cost, is the additional cost imposed on third parties or society, such as environmental contamination, health damage, water treatment, and remediation cost. When production decisions are based only on marginal private cost, firms and the consumer ignore the marginal external cost, leading to overproduction relative to social optimum. Obviously, the marginal social cost associated with Pfas production use should be measured of the marginal private cost directly borne by firm producing or using Pfas. And this measure indicates that the cost imposed on society is greater than the cost paid directly by producer users. And this means that the market price not fully reflects the environmental, health, and remediation costs generated by PFAS. And for PFAS, firms producing or using PFAS benefit from lower production cost, enhanced performance and durability, none of which reflect cost borne by third parties of public systems. So there is the private cost asymmetry. On the private benefit side, PFAS confer industrial performance advantages such as thermal stability and chemical resistance, or product durability related to packaging or cookware, or reduced short-run production cost. But on the social cost side, there are water treatment cost, soil remediation, or healthcare expenditures linked to the cancer, immune suppression, and thyroid dysfunction, and reproductive effects, or environmental monitoring and laboratory testing, and agri-food losses from market, from recalls, exclusion, and compliance. So the graph show the canonical negative externality. The market equilibrium occurs when demand intersect marginal private cost generating quantity Q market. And the socially optimal quantity Q is lower at the intersection of demand and marginal social cost, and the shaded welfare loss represent the economic damage from overuse of PFAS. And for PFAS, the divergence is particularly severe because the external costs are delayed related to latency, or they are geographically dispersed about mobility, and they accumulate over time about persistence. So this means the welfare loss is not a one period problem, but it compounds with each year of continued use. So the theoretical extension is related to the persistent externality. The Pigouvian model assume contemporaneous localized attributable externalities, but PFAS violate all three conditions, but related to persistence. PFAS remain in soil, water, and human blood for decades, and once released, the cost stock grows regardless of future regulation, or about the mobility. PFAS travel via groundwater, surface water, food chains. About the cumulativity, small individual release and aggregate into system contamination, latency, about the health effect appear years to decades after exposure. About intergenerationality, current production decision impose cost on future generation who bear no responsibility for past choices. Um, so, contamination, PFAS enter in agricultural system through a contaminated irrigation water, through biosolid application used as a fertilizer, carries industrial PFAS loads into agricultural soil, or through food content materials, through packaging coatings and containers. Can PFAS transfer to food products or atmospheric deposition? And the European Commission reports for specific ecosystem service case studies, the effect on pollinator and food provisioning, the effect on poultry and livestock, and the effect on agriculture, and the effect on primary producer and food herbs. So the categories of external social cost are related to the water treatment, soil remediation, health cost, environmental monitoring, agri-food losses, and the reputation. For example, territorial image damage to PDO and PGI products and the local food system. And each category corresponds to a component of marginal external cost in the Pigouvian equation. So these are three numbers that aren't just a statistic. So they are empirical proof that divergences between private costs and social costs that Pigou theorized in 90s, 20s is real, measurable, and in the case of PFAS, enormous. And the market has priced PFAS as if they are cheap, and the society has discovered they cost hundreds of billions, and this is a market failure we need to correct through policy instruments. And the central Pigouvian insight is that these costs are not embedded in the market price over PFAS containing products, and the market systematically underprices PFAS use by failing to internalize this future cost. So the observed market price of PFAS containing products reflect only private production cost plus normal profit margin, and however it excludes the present value of future health treatment cost, the water treatment and monitoring cost, and the about soil remediation cost, the ecosystem service losses, intergenerational welfare transfers. And this is a Pigouvian missing signal. Because the signal is absent and the consumer producer receive incorrect incentives, and the firms produce more PFAS related output than is socially optimal, and households use more PFAS containing products than welfare maximizing. However, public budget absorbs cost that should have been reflected in the private prices, and this is not a temporary market imperfection, but it is a structural feature of Pfas economics that requires policy correction. And the price formed by the market is the green box on the left, and the cost borne by society is the red boxes on the right. And the arrow in the middle is the missing signal. No market mechanism automatically transfers this cost back to the firm that generate them. And this is precisely why Pigou argues for a corrective tax to reconstruct that missing signal and bring the private price back in line with the true social cost. This is the cost shifting across the agri-food value chain. The actor bearing PFAR-related costs are often not the original producer or users of PFAS. And this is the externality cascade in the food supply chain. Farmers and food firms are particularly vulnerable because they require clean water as a production input, but agricultural land contamination is long-lasting, and the food safety exigencies can force product recalls with compensation from original PFAS user. So agri-food specific inflation is related for four dimension of vulnerability about production risk related to contaminated irrigation water, food safety risk. Obviously sets maximum PFAS levels in animal products, and about reputational risk, then the territorial contamination can damage PDO and PGI levels, and related to informational asymmetry. Consumer cannot directly observe chemical contamination in food, and creating a market for lemons problem that compounds the Pigouvian failure with an informational failure. So the Pigouvian framework justify a set of coordinated instruments, a Pigouvian tax, a levy on PFAS production or emission equal to marginal external cost, aligning that private incentives with the social cost, or polluter pay principles about extended producer responsibility, shifts life cycle environment costs to manufacturers, or use restriction and ban related to banning non-essential uses, reduces a flow of new contamination, and mandatory monitoring about marginal external costs cannot be estimated, or prices or subsides for PFAS-free alternatives. So these are the prevention, the cost of inaction is related in economical point of view with current policies trajectory, or about the control. We have the difference between these two costs as having of 110 billion. So the contribution connects six stages into coherent Pigouvian narrative: production and the use, the private benefit captured by industry, the environmental release, and the persistent contamination, and about the external cost, about health remediation, food safety, and the ecosystem losses are borne by third parties, and the market failure is realized when marginal social cost is measured than marginal private cost because price don't reflect step 3 and step 4, and the internalization about Pigouvian taxes, liability restriction, and correct the divergence. And the theoretical contribution show that PFAS are not simply a pollution problem, but requiring standard environmental regulation. So this contribution is focused on a theoretical contribution related to PFAS that are persistent negative externalities through a Pigouvian analysis. And then there is a contribution about the agri-food sector that PIFA maps the external cost through supply chain and exposing farm food firms and the territorial food system, and about policy contribution. By grounding the analysis in welfare economics, this contribution provides rigorous rationale for Pigouvian taxation and polluter pays. And this contribution is focused on the economic damage from PFAS outlast the production that generates it. And PFAS, in conclusion, is not only an environmental and health risks, and it is structural failure of the price system to capture persistent social costs. And the Pigouvian framework offers the most rigorous academic rationale for public intervention. Thanks for attention.